Lesson 4.2, Day 1. Our learning target says I can represent a linear equation in all forms. Our essential question says how do you write an equation in slope-intercept form when you know the slope and one point on the line? Well, slope-intercept form is the form y equals mx plus b. Remember, m is the slope of the line and b is the y-intercept. So what's going to be a little bit different today is that we aren't given the slope and the intercept. We're given the slope and one point on the line, and we're going to learn how to write the equation in slope-intercept form. So then you graph lines given the slope and the y-intercept. Now you're going to write an equation of a line in slope-intercept form given the slope and one point on the line. So not necessarily the intercept. And then number 2 says we're going to write an equation of a line in slope-intercept form when we're given 2 points. So we'll work on that skill tomorrow. Now the Y slide says in 2006, the attendance at the Columbus Zoo and Aquarium was about 1.6 million. So in 2006, it was about 1.6 million. In 2009, the zoo's attendance was about 2.2 million. You can find the average rate of change for these data. Then you can write an equation that would model the average attendance at the zoo for a given year. Okay, so the first skill that we're working with today, we're just working with writing an equation in slope-intercept form given a point and a slope. What I'm going to do is I'm going to teach you 2 different methods for this problem. I like you to have more than one way to get to your answer. So I'm going to show you 2 different methods, and then you can choose whichever one you like the best. Okay, so the first method is going to be my point slope method. Okay, so this is point slope. Because we're given a point and a slope, it could make sense to use point slope form. So y minus and then x minus. So my point has an x coordinate of 2 and a y coordinate -3 and a slope of 1/2. So this is what my equation would look like in point slope form. And if I solve it, because my answer has to be in slope-intercept form, I need to get y by itself, so I can distribute the 1/2. So y plus 3 equals 1/2 x minus 1/2 times 2. The 2's would cancel. So half of 2 is just 1. And then I'm getting y by itself, so I would have to subtract 3 on both sides. So y equals 1/2 x minus 4. So that's my answer in slope-intercept form for the line through the point 2, -3 with a slope of 1/2. Now, if you would like to use slope-intercept form right from the start, let me explain how that works. This is an equation in slope-intercept form. Now, we know that when we're given a point and a slope, the point can represent any x and y coordinate. So here's the deal. With the information that we're given, I can substitute the point for x and y, and then the slope is still m. So if I use this equation, I can substitute -3 for the y coordinate, 1/2 for the slope, 2 for the x coordinate, and then solve this equation to figure out what the y-intercept is. So see if you're following what I'm doing. I'm taking the point and replacing x and y with 2 and -3, because any point on the line is going to be a solution in the equation. Any point can be substituted for x and y. So if I multiply 1/2 times 2, that is 1. So now look at the equation that I have. So this time I'm trying to find b, the y-intercept. So if I solve this equation for b, I need to subtract 1. So negative 4 equals b. Then I can write my answer using this slope and this intercept. So y equals 1/2 x minus 4. So I got to the same answer in a little bit different way. So if you like using point slope, you substitute the point in the slope and you solve the equation to get y by itself. If you like using slope-intercept, it does look like a little bit less work. What you have to remember though is that the x and y in the slope-intercept form can be replaced with the ordered pair coordinates x and y. So it's just a little bit more confusing maybe, I guess, but either way you get the same answer. So 2 methods again. So I'm going to use point slope one time, and I'm going to use slope-intercept the other, so that you have 2 choices. So first one, point slope. My point would be x1 and y1, and my slope is m. So y minus 4 equals negative 1 times x minus negative 3. This would turn into a plus. I distribute. So y minus 4 equals negative 1x minus 3. And then I'm trying to get y by itself. So I would have to add the 4. So y equals negative 1x plus 1. Okay, my other method. This time, if I erase these 1s, this time I am going to replace y with 4, replace my slope with negative 1, replace x with negative 3, and we're trying to figure out what b is. So negative 1 times negative 3 is 3. So 3 plus b equals 4. I'm solving for b. Subtract the 3. So 1 equals b. So make sure if you use this method, make sure you remember that you're actually trying to write a slope-intercept equation for the line. So you have to remember to write the equation at the end. So I plug in my slope, which was negative 1, and my intercept is positive 1. So either way, y equals negative 1x plus 1. All right, now we've got a word problem. Joe needs to have his car repaired. The parts will cost $145, and the mechanic charges $60 an hour for labor. All right, so the slope or rate of change, the rate of change is the $60 per hour. That's the rate of change. The y-intercept, or the starting point, that's $145 because you have to pay for the parts first. So for number 1, if I write an equation to represent the total cost C for H hours of labor, I'm going to need C equals H hours of labor. So that's going to be 60H plus 145, the y-intercept. Now, part 2 says if Joe paid $355, how many hours did it take the mechanic to fix his car? Well, $355 is my total cost. So here is the equation that I'm going to be solving. So $355 equals 60H plus 145. So let's solve for H. Subtract 145. So 210 equals 60H. Divide by 60. And 210 divided by 60 is 3.5. So 3.5 hours, 3.5 hours is how long it took the mechanic to fix his car. So when you're trying to write an equation, You always want to try to figure out what the numbers are that they're giving you. Remember, a y-intercept is a starting point, or like for this situation, it's the cost at a time of 0. Because before they start any repairs, you have to get the parts. So the parts are the first thing that you're charged for. Then the hourly charge is for the labor for fixing the vehicle. All right, next one. Grant is ordering tickets for a hockey game. There's a processing fee for each order, and the tickets are $45 each. Grant ordered 6 tickets, and the cost was $285. How much was the processing fee? Okay, so first off, I just want to think about this information. The tickets are $45 each, and he got 6 tickets. So I need to figure out how much 6 tickets should cost. Okay, that's $270. But it says that he was charged $285. So if that's how much he had to pay, and the tickets were $270, if I subtract those, that leaves $15. So number 1 was asking how much is the processing fee? It's $15 because it's the difference between what he paid and what the 6 tickets should have cost. So $15 processing fee. Processing fees are very common when you order tickets for an event or a concert. Okay. Or sports game. Okay, number 2, write a linear equation to represent the total cost C for T tickets. So total cost C. So C equals, well, each ticket was $45. So I'm going to go with 45T, $45 for each ticket, and then plus that $15 processing fee. So this is the amount per ticket, cost per ticket, that's your rate of change. And then the processing fee that we figured out, that's happening only once. The processing fee is like the y-intercept. And that was my last example.